Many of us expected this would be a mission of major discovery, but I think none of us really expected the degree of discovery, the degree of diversity which we found in the outer solar system.
We were lucky. We had the unique opportunity to explore planets that man had never been to before.
But Voyager didn't only carry sophisticated instrumentation, it carried the hearts and the minds of its creators and all of us who were privileged enough to see what it saw.
And it will be unique for a long time, because there isn't anything else out there to explore for which you can get as much return from a single system.
I think Voyager will be remembered as part of the few decades where human race left its planet. And Voyager will be a main chapter in that book.
Voyager kind of opened up the outer planets to everybody, and I think they were vastly more interesting than we expected, up to and including maybe even especially Neptune.
You only explore the solar system for the first time once. And we did it.
The outer planets are giant planets. They're distinctly different than the smaller rocky objects in the inner solar system, such as Earth, Mars, Venus, and Mercury. And Voyager was designed to open up to exploration these giant outer planets, which are spheres of rotating fluid and gas surrounded by 57 moons totally. Each planet has a unique ring system, and they have magnetic fields which were immense compared to the magnetic field of Earth. Voyager's job was to explore those worlds in the outer solar system.
Scientists at Cape Canaveral, Florida, sent another unmanned Voyager spacecraft on its way to Jupiter and Saturn today. It lifted off flawlessly at 8:56 a.m. and had none of the problems of the Voyager launch 2 weeks ago. This Voyager presumably will get to Jupiter in March of 1979.
Voyager 2 scared us. Voyager 2 had problems in separating from the solid rocket kick stage. The spacecraft today, have a few problems, but most of these problems were problems we experienced early on. In other words, the Voyager 2 spacecraft has a failed receiver and a sick backup receiver. That's the most serious problem on board that spacecraft.
The way we communicate with the Voyager spacecraft is that we send commands to the spacecraft, a series of digital bits in computer language that go to the spacecraft, and it's the language that the spacecraft understands. These bits are transmitted from ground stations located around the Earth, what we call the Deep Space Network.
The 3 Deep Space Network stations are located in Goldstone, California, outside of Madrid, Spain, and outside of Canberra, Australia. As the Earth turns, we can maintain continuous communication with a point in space, the spacecraft.
In turn, there's kind of the reverse link coming back down. The information that the spacecraft gathers goes into a transmitter on the spacecraft. It's transmitted into those big ears on the ground of the Deep Space Network and transmitted back then on the ground to our control facility here in Pasadena. The transmitter on Voyager is like tens of watts. It's like 20 watts, less power than an average light bulb on your front porch might consume. On the other hand, when that signal is received on the Earth, it is literally a tiny, tiny fraction of a watt that is received. The amount of power received by the ground antennas is something like 1 billionth of the amount of power used by my digital watch.
Man has known about the planet Jupiter ever since he took a good look at the night sky. It's not what you'd call a near neighbor, though, being more than 400 million miles away. But after all these centuries, we're getting a closer look than we've ever had.
When Voyager got up close and we looked at the time-lapse movies of the atmosphere in motion, things were changing every day. Little storms would pop up out of nowhere and they'd get ripped apart, dispersed all in a day or two. And that made the mystery of the great red spot and those other large spots even deeper, because how could they last for so long in the midst of all that chaotic motion? It was a startling discovery.
As Voyager approached Jupiter, the first thing that it intercepted was what's called the bow shock. That's a shock where the supersonic solar wind becomes subsonic. And that shock, the solar wind velocity, which is 1,000,000 miles per hour, abruptly decreases to 250,000 miles per hour. That abrupt change in velocity causes the ionized gas to vibrate. And we can sense, we can hear the shock, and we can hear the vibrations associated with that shock as the spacecraft flew through the shock itself. We had expected that the magnetic field might extend something like 1,000,000 miles or so from the planet. In fact, it extends some 3 to 4 million miles from the planet. Now we understand, because Io is injecting into the magnetic field some 1 to 2 tons of material every second. And that material, as it spins with Jupiter, is centrifugally expanding Jupiter's magnetic field and inflating it to a much larger size than it would normally be.
We expected, quite frankly, the satellites of the outer solar system to be quite bland and geologically lifeless. As we flew closer, Io looked less and less like anything we'd ever seen. The impact craters turned into irregular dark patterns, and the colored patches, red, yellows, painted on the surface. As a matter of fact, as we flew closer, we saw nothing at all that resembled an impact crater. Voyager 1 discovered 11 active volcanoes, and 9 of those were still active when Voyager 2 returned 4 months later.
I think the event in the mission which really altered our view and our expectation for the rest of the mission was the discovery of the volcanoes on Io. That was such a dramatic and unexpected thing to find that it really told us that we could no longer be complacent. We could no longer expect to understand or anticipate what we were really going to see.
Voyager 1 flew in close to Io for a close-up flyby of Io to give good return from Io, and made its close encounters with the Galilean satellites after the closest approach of Jupiter.
If we look at Callisto, it's one of the most heavily cratered objects in the solar system, virtually saturated with impact craters. When we looked at Ganymede, we find 2 kinds of terrains. One is a terrain that looks very much like Callisto, but in addition, Ganymede has a very complex intersecting network of faults in a younger terrain, which has evidently welled up from the interior and replaced this old cratered terrain that's so similar to Callisto. In the case of Europa, we see yet another style. We see gargantuan fault patterns in which this ocean has frozen repeatedly, broken open, and fluids float up to the surface, producing dark puddles of material within the faults. These are then broken again, so there's intersecting and cross-cutting networks. There were 2 small satellites discovered at Jupiter. One of them found orbiting just outside a very thin, tenuous ring of material that was discovered at Jupiter.
The imaging team members planned one single photo, an 11-minute exposure that would be taken as the spacecraft plunged through the equator plane of Jupiter. And it just so happened that there was a ring there. It's dusty, and there seems to be no indication of water or ice within the ring, so it's probably made out of rocky material.
An outer space spectacular that was the stuff of dreams only a generation ago began snapping into the sharp focus of reality today after its billion-mile journey from Earth. The Voyager 1 spacecraft